Good morning, folks. I hope that you guys are having a good day. I hope that you enjoyed your weekend. Today is Monday the 14th. We've got an exam tomorrow on Tuesday the 15th. Today, not introducing any new material. I'm going to go over some of the high points for the exam, and give you some, pointers on what you should review, what you should know. You guys do have the practice exam that's up on Canvas, so absolutely take a look at that. Make sure that you do that. Um, that practice exam and all of your other practice exams are written with the intent of this should help you out. That's kind of what I'm going for with that. So I want you guys to have that as a resource, and not just have it as a resource, but have it as a worthwhile resource. Um, this exam, and this is recording, right? Yeah, good. Um, some of the parameters about this exam. I've gotten some emails, or actually, let me take it kind of from the top. I've gotten some emails about folks asking about taking it online, and I have no problem with that. I'm just going to add you to the cohort of online exam takers. Um, And so I will do that today. I'll send out an email a little bit later this afternoon that says, hey, you're on the list of people who have contacted me about taking the exam online. You should see it online as of now. Um, or you should see it as like a quiz that you have to take, or a pending quiz or something like that. Um, and in the event that you don't, please contact me. So there's that. Then what the for those of you who are taking the exam in person, I got to pull up CatsWeb here so I can see the actual room number that the exam is in. Okay, I've received a couple of emails from folks asking about taking it online, and I have not responded to those yet. Um, I'm going to kind of sift through those and get those sorted out before, and so I'll add folks to the list. And then, like I said, this afternoon I'll send you an email that says, "Hey, you contacted me about taking the exam online. I've added you. Can you confirm?" Let's see. For those of you who are taking the exam in person, we will be in, where's our classroom number? The San Marcos Club, blah, 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 blah. In Centennial Hall G01. So go ahead and move. Just have to move some things around real quick. That's plugged in. Then this should, yeah, there we go. Okay, so in person exam, Centennial G01. Um, and the exam will start at 10 a.m. and you have 60 minutes to take the exam online. Well, that is Zoom, or not Zoom, I'm sorry, Canvas/Proctorio, and that will open, I believe, at 9:30. I'm setting it to open at 9:30 a.m. and it will close. Because it's online, we have a little bit different flexibility and constraints. And this Proctorio is kind of the proctoring service. You'll have 60 minutes, but you can take it anywhere between 9:30 a.m. and 8 p.m. Now, the part of the reason for that 8 p.m. is some people who are taking the exams online have contacted me and they said, is it possible for me to take it later in the day because of my work schedule? And my answer to that is sure thing. Um, like I said, if you see this and you're like, oh man, I want to take it online, contact me. Um, we have the flexibility, so I'm going to respect that and grant that. So contact me if you'd like to take the exam online, is my point. So can I get a number in the chat if you understand kind of the exam parameters in terms of timing and what it takes if you want to take it in or online? Okay, cool. Um, Next item is, well, what does the exam consist of? It's 30 questions, and you'll have 60 minutes. The only time that someone's going to have more than 60 minutes is if they have some sort of ODS accommodations. Um, and if you do have those accommodations, but you have not contacted me, then you need to. It's not really something that I can retroactively apply. It's not like you can take the exam and then say, oh, well, I needed an extra hour, or I needed I'm afforded extra time. Um, what I can do then is say, okay, well, we'll do that for all the upcoming and subsequent exams, but after that, after this first one, no, I'm sorry, we can't do that. If you're an online exam taker, that's a very easy to adjust the time constraints there. So if you have accommodations and um, have not contacted me, do so as soon as possible. To my knowledge, there's only one person in this class who I have communicated with, and we're all set. So if you're thinking to yourself, "Oh yeah, I have accommodations," I don't remember that conversation with Dr. Gray though. That means it hasn't happened, and that means that we need to get the ball rolling on that. Again, it's an easy accommodation to make, and I'm glad to do so. Um, if you're an in-person exam taker, though, and you're planning on taking your exams at the testing center, I don't know about the timeline on getting that to them. Again, if you want to try to schedule something for tomorrow, go for it. I will do my part to support you on that. All I have to do is send the exam over, so it shouldn't take too long. But again, Texas State is a university of 40,000 people, not in the summer necessarily, but there's a lot of people and resources are a little bit lower, so personnel might be lower. So availability to do a testing center exam might be a barrier. Okay, so 30 questions, 60 minutes. These 30 questions are going to come from our first 2 weeks of material. Now, one of the kind of challenges with that is that's a lot of stuff that we've covered. How do you get good questions from all that stuff that's worthwhile? You know, I try to evenly distribute the material and I try to make the exam reflect that of the practice exam. There are times, there are times whenever I write a practice exam and I write an actual exam, and it's like, man, that was spot on. That was exactly what I wanted, and that's exactly what the students needed. Um, but I will say that I that's an area for improvement for me, or that's an area that I still am working to improve on. Um, so if you take the practice exam and then you're like, all right, I'm ready, and then you take the actual exam, and you're like, what on earth was that practice exam? Um, I would just say keep doing the practice exams because sometimes I do a better job of getting a practice exam that serves you guys and still is challenging and kind of is balanced with the actual exam itself. So I'm still working to improve on that, and I hope the practice exams are good for you guys. Um, but like I said, it's still an area where I'm working on it. If during the exam you see, hey, wait a minute, this question was repeated. Oh man, or this question's asking kind of the same thing, or these two answer options are kind of the same. What I would say to that is before I release the scores of the exams, I always look back at all the exams. I always do the exam to develop the key. And then I go back and I'm like, okay, well, this is right, this is right. Oh, wait, I have a duplicate correct answer there. That's not what I intended. Um, and so I do account for that. So I try to have as few mistakes as possible. I'm really always aiming for zero mistakes. Yeah, zero mistakes. But that's again something that I'm working on. But in the event that you hit a question, you're like, question 19, what, you know, the two answer options, they seem like they're the same, but you know, you're welcome to email me and say, hey, I looked at question number 19, or hey, I can't remember the exact question, but it was something about valence electrons. Email me or say, hey, I'd like to join you in office hours. Could we talk about question number 7? And I'm glad to pull up your exam, look at that, and look at the different answer options. So I like to kind of remain open to discussion and conversation, but at the end of the day I am going to say, like, well, this is the right answer, this is the wrong answer. If there are two right answers as answer options, I'm going to give credit for both of them. I'm not going to be like, oh, well, this is the one that I wanted. No, I'm not going to do that. Okay, so those are some of the important details. Now, in terms of content on this exam, we've got a lot. Um, there's some things that are worth going back to. For instance, um, physical, physical, and chemical properties. If you understand physical and chemical properties, it's also going to be important for you to understand physical and chemical changes. Now, there's a little bit of overlap between these two, because if you understand one of them, you probably understand the other. Um, Now, a physical property, an example would be something like density or hardness. Density is a physical property that's quantitative. We talked about determining density of something. This is our first place where we have a calculation. And this would be the mass over the volume that something occupies. We talked about measuring volume by displacement. So if you have a 39.6 gram piece or sample, we'll just say, and you add it to a graduated cylinder, and that graduated cylinder is set to 29.00 milliliters. You add that sample, and the volume goes up to 31.2 milliliters. Well, then you'd be able to say, okay, well, this sample has a volume of 31.2 minus 29. It displaces, it causes the water level to go up 2.2 milliliters. So effectively, what we could say is 39.6 divided by 2.2. And that would be our density, the mass over the volume. Now, a chemical property or a chemical change, a good example of a chemical change is to look for, or good ways to look for chemical changes, to look for keywords like rots or spoils or ferments. Or, you could say something like, um, setting a glass of milk out in the sun for 4 hours, or after setting a glass of milk out in the hot Texas sun for 4 hours, it begins to smell bad. What has taken place? Begins to smell bad, and it has chunks in it. Well, you might think, oh, well, Chunks. Ooh, well, it's changed its consistency, but it smells. Okay, well, what's happened there is that a chemical change has taken place because the key indicator, the key word there was it smells. Now, how do you describe any sort of changes in, oh, it's a solid versus a liquid? Well, that's kind of a gray area. Um, I would argue for that, it's still going to be a chemical change because whenever milk solidifies like that, what's happened is the proteins in milk, they have denatured, they've changed shape. And so those shape changes are a result of chemical reactions. Now, in addition to that, we talked about numbers. We talked about scientific notation. We also talked about unit prefixes. Now, one example is to go from 1 kilogram, and this is variable, kilogram. I could replace gram with liter. I could replace gram with, um, let's see, any other kind of base unit. Lumens, for instance. Um, a kilogram is a mass. So 1 kilogram is equal to 1,000 grams. 1 gram is equal to 1,000 milligrams. When you have that, you could say, okay, well, 1 kilogram is equal to 1,000 times 1,000 or 1 million milligrams. So here's our discussion, or here's kind of the high points of unit prefixes. Scientific notation. Well, when you're writing a number in scientific notation, you would do something like this. If I had 1,290,000,000 dollars, if I had that many dollars, and I wanted to write that number using scientific notation, what I'm going to end up with is 1.29. I'm going to end up with 1.29 because the convention or the kind of rules for scientific notation is you have a number followed by a decimal followed by whatever non-zero digits. These zeros right here, I'm going to drop those. But 129 is not the same as 129,000,000. So what I need to do is I need to account for that. And the way that I account for that is by saying times 10 to the something power. Now, the something power is I'm going from a number in full notation to scientific notation. My decimal place is effectively right there. I am moving my decimal. 1, 2, 3, 4, 5. Somebody's unmuted. 6, 7. I don't mind somebody being unmuted, but are you intended to? Do you have a question, Ian? Ian?
Mango strawberry and then
And a sandwich.
You had a sandwich?
sorry.
I'm not sure if there's a microphone issue. I'm going to mute you. You can unmute yourself if you want to. I wasn't sure if that was intentional or not, or if you have something to add it to the chat, please. Okay. So I've moved my decimal place. I move my decimal place 1, 2, 3, 4, 5, 6, 7, 8. So 1.29 times 10 to the eighth. That is the same in scientific notation and full notation. Okay, so those were ways that we talked about numbers. If our number is written in full notation like this, 0.0000036, I'll erase the units. And I wanted to write this in scientific notation. It'd be 3.6 times 10 to the 1, 2, 3, 4, 5, negative 5. Okay, so that is, or those are some of the high points of kind of numbers. The last one that I wanted to talk about was the conversion. We talked about degrees Celsius versus temperature measured with Kelvin. If it's, add to the chat, if it's 12 degrees Celsius, what is the temperature in degrees Kelvin? I'll give you a hint. It's not 12. I'll give you another hint. It's a positive number. 285. Great job. So it's at about 285 degrees or 285 Kelvin. So sorry about this. I don't know what happened there. Okay, so 12 degrees Celsius, 285 Kelvin. If you get that, that's going to put you in a good place with respect to conversions. Similarly, 299 Kelvin is 26 degrees Celsius. You're either adding 273 or you're subtracting 273, depending on what unit you're starting with and what you're going to. Then the other thing about the Kelvin scale, this scale is an absolute scale, which means that the temperature is never lower, or let me rephrase that, never negative. So if I told you, hey, it's negative 44 Kelvin outside, you'd say that's literally impossible. All right. Let's see. We talked about different laws of chemistry, laws of definite proportion. And we also talked about the law of multiple proportions. Now, these two laws are kind of interesting and valuable to know. For example, let's go with this compound, CO2. That's something that you exhale. It's a natural waste product from, well, burning sugars, burning fats. It's what your body releases through your lungs. And carbon dioxide is always one atom of carbon and two atoms of oxygen. There is also something known as CO, or carbon monoxide. Okay, so these two different things both consist of carbon and oxygen. This is a demonstration of multiple proportions, or the law of multiple proportions. They are both made up of the same thing, but they vary a little bit. Carbon monoxide is always one carbon, one oxygen. Carbon dioxide is always one carbon, two oxygens. So these two things are defined independently, but They are both made up of the same thing. They are both made up of carbon and oxygen. So that's how it's the law of multiple proportions. It's almost like you could visualize it as a piece of art, like one painting, a stop sign is red and white. The end. That's all that it is. Well, if you took red and white, do you have to paint a stop sign? No. You can paint any number of things. You could paint a clown nose or a boxing bag or something like that, a speed bag. The reason that I'm saying speed bag is because there's one in my office right here. So that's why. Okay, so definite proportions, multiple proportions. Those are two different um, important laws to understand. Then, in addition to that, we talked about atomic structure. With respect to atomic structure, we have three subatomic particles: protons, neutrons, and electrons. Okay, protons, neutrons, and electrons, those are our subatomic particles. Protons are positively charged, neutrons are neutral, and electrons are negatively charged. If we have a lithium atom has a nucleus, and that nucleus consists of 1, 2, 3 protons and 1, 2, 3, 4 neutrons. Those two things make up the nucleus. They give an atom its atomic mass. This atomic mass of this isotope is 7. There is another lithium, and this would be lithium 7, lithium 8. Well, let's go with lithium 10. Lithium 10 is also going to have a nucleus, but it's going to have a different weight. Its weight is going to be, well, 10. Could somebody add the number? How many protons am I going to have in this nucleus? Add it to the chat. 3 protons. 1, 2, 3. How many neutrons? Perfect. How many electrons? If it's neutral. Try again. 3. Our electrons are negatively charged. They cancel out the charge of our protons. So this nucleus is going to have 1, 2, 3, 4, 5, 6, 7. I'm going to have 7 neutrons, 3 electrons. Now, what we did with this was, okay, so this talks about different isotopes. And these are different isotopes because they have different atomic masses. I'm going to erase this right here. And I'm going to draw 2 different lithium. 1, 2. There's one of them. One, two, three, N, 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 N. Okay, so first question, Y or N, are these 2 different isotopes? Nope, they are not different isotopes. You are absolutely correct. They have the same atomic mass. What is the word to describe these differences? We call these 2 different things different whats? Ions. Perfect. These are different ions. The ion on the left, what is the charge of the ion on the left? -1. What's the charge of the ion on the right? +1. Which one of these is a cation? Tell me the one that has, or tell me the charge of the one that is a cation. Now tell me the word that corresponds or kind of is the opposite of a cation, um, that is applied to the other ion. Anion. Perfect. Great. So we talked a lot about atomic structure, where these different things are. One of the other things that we talked about were these different colors. So all of these different materials burn, or these different metals and different materials are going to burn and produce different colors. Boron, for instance, is blue-green. Sodium is kind of an orange. Lithium is a little bit more of a reddish pink. Potassium is definitely more of like a pink blue. Iron is blue orange. Barium is similar to boron in that it's a little bit of a blue green. Strontium is a bright red like a lithium. Calcium is orange, sort of like sodium. Copper is a greenish blue hue. So these different materials burn and give off different colors. I think that when you're looking at this, it's helpful to see, okay, well, sorry. God, my PowerPoint is deciding that it likes to run a little bit slower than I want it to. And so then I'll click to advance a slide or click on the screen to do something, and then it'll be like, oh, would you like to close? And my answer is no, I do not like to close. Okay, so when you're looking at these, if you look at, for example, lithium and strontium, they have similar colors. Sodium and calcium have similar appearances to one another. And in part, that's because of the makeup of these two different materials. On your exam, you will have a periodic table so that you'll be able to look at that. Um, and so you'll have that as a reference point. And with respect to that, it's going to be helpful to remember the valence electrons that a given atom has. So if we look at the periodic table, here's my very crude model of it. I'm not even going to draw the lanthanides and actinides. 1, 2, skip a few, 3, 4, 5, 6, 7, 8. Okay, now if I tell you that fluorine is right here, what is the term that's relevant to fluorine with respect to a property that fluorine has? Fluorine is the most what element on the periodic table? Starts with an E. Not quite. Electronegative. That means within a bond, fluorine wants to get those electrons more than the other atom. Fluorine's the most electronegative. Can you tell me in the chat how many valence electrons does fluorine have? Perfect. Fluorine has 7 valence electrons. Can you tell me, and think about the octet rule, tell me how many electrons does fluorine like to get, either by having them borrowed or sharing them? It likes to get 1 electron. In which case, what is the common ion of fluorine? Yeah, we say F minus 1 or F minus. Now, right next to fluorine is oxygen. What's the common ion of oxygen? Perfect. O2 minus. Can you tell me what is the name, full name of the common O2 minus ion? What I'm getting at is it has a suffix. What is that suffix? Oxide, perfect. The oxide ion. Now, if I were to draw the Lewis structure of the oxide ion, well, I put the symbol for oxygen. And I put 1, 2, 3, 4, 5, 6. 6 electrons are the number of valence electrons that oxygen rolls in with. But I talked about drawing the oxide ion, in which case it picks up 1, 2 more electrons. I'm going to put a bracket around that and say 2 minus. So that is the oxide ion. Now, fluoride ion. Same thing. 1, 2, 3, 4, 5, 6, 7, 8. Minus 1. So does this at all relate to number of protons, neutrons, or electrons? Not protons, not neutrons, but certainly electrons. Now, can you tell me, since fluoride likes to gain 1 electron, can you tell me what the charge, or sorry, how many bonds does fluorine like to make? Perfect. Can you tell me how many bonds does oxygen like to make? Perfect. Great. How about carbon? And you will have the periodic table, and I'll go ahead and kind of complete this a little bit. How many bonds does carbon like to make? Fantastic. Okay. We talked also about naming compounds. This IDE suffix is a really big part of that. For example, sodium chloride. That is NaCl. That can you tell me what type of compound that is? Your 2 options are, well, I'll give you a couple of different options. A covalent, ionic, metallic, Metallica, Megadeth, Slayer. Well, I'll tell you, it's not Slayer. It's not Megadeth. It's not Metallica. It's not metallic. Perfect. It's a no, I'm sorry. It's not a covalent compound. This is an ionic compound. The way that you can remember that is good. Good. I'm happy to read that, Ryan. Sodium's way over here. So based on that, how would you classify sodium? Just based on where it is on the periodic table. I'll give you a hint. It starts with an M and it ends with an ethyl. This is a metal. Okay. How would we classify Cl over here? Perfect. When you have a metal and a nonmetal come together, you make an ionic compound. What type of compound do you make when you have 2 nonmetals come together? Perfect. Covalent or a molecular. A metalloid, I'm happy that you brought that up, Julia. A metalloid is kind of within this range. Those are the elements within that range of the periodic table. And these metalloid, they have properties of metals metals and I'll say props of metals and nonmetals. Okay. All right. So I think that's pretty much most of the high points that I wanted to go over. Um, oh, whenever you're doing can you tell me, add to the chat, what is the name of this compound? CO. Tell me the name of that compound in the chat. That is incorrect. Carbon monoxide is correct. Why is it monoxide as opposed to dioxide? One oxygen. Why isn't it monocarbon monoxide? Or let me rephrase that. Is monocarbon monoxide, is that a better name? Add a Y or an N to the chat. No, it's not. When we have, so you never apply the number prefix to first element. So then what is, if you saw this right here? Actually, let's scrub that. What's the name of that compound right there? Nitrogen trioxide. Now, my next question is, do these two compounds right here, first of all, add a Y or an N to the chat. Do these two compounds have the same charges? No. Add a Y or an N to the chat if you would agree that one of these has a negative charge and one of them is neutral. Great. If you understand that, you're in a really great place. Since they have different charges, they have different electron compositions. Add a Y or an N to the chat. Do they have the same name? No, they don't. Since they have different charges, one of them we classify as an ion. Which one, tell me in the chat, which one of these you classify as an ion? The negative one. Exactly. NO3 minus is the ion. Okay. How many atoms make up NO3 minus? N O O O. 4 atoms. If you have multiple of something, what's the prefix or what's the word that we use to describe that? Poly. So would it be fair to call this a polyatomic something? Add a Y or an N to the chat. Yeah. Would you call it a polyatomic atom or a polyatomic ion, do you think? Add an I for ion, A for atom. Perfect. Now, I'm going to ask you this. This one right here is a polyatomic ion known as nitrate. Okay, so NITR, nitrogen, ATE? What? That's not something that you're going to be expected to memorize or know. I would provide you with that. Is this that I put a box around, is that a polyatomic ion? Wire it into the chat. No, it's not. Okay. Um, does anyone have any questions? Okay. Well, tomorrow during the testing period, I will be on Zoom. So if you are a um sorry, if you are a online test taker and you encounter an issue, you can join the Zoom and ask me a question. Um Someone else will be proctoring the exam tomorrow, and that is Ezra Hackler will be there. He will be in GO1 tomorrow to greet you guys. Um, and he will have access to the Zoom. So if there's any questions, he can follow up and ask me. But I also want to add that, the exam, like, if you encounter an issue on the exam, just make note of it, email me and say, hey, what's going on? I don't understand why you have these answer options or something like that. I expect that I'll get the grades back to you before the end of Wednesday, just because there are testing center exams that have to be processed, and I'll go from there. I'll take all those into consideration before I display all the grades. If there are no other questions, I hope you guys have a wonderful afternoon. If something comes up today or tomorrow, email me and I will get back to you as soon as I can. I'm going to be adding folks. Yes, I will be uploading today's review and I have to upload Fridays. Um, if there are outstanding emails from you that I haven't responded to from this weekend, I will be doing that today. And there we go. The exam, if you're taking the exam in person, it will start at 10 a.m. in Centennial Hall GO1. If you are taking the exam online, you can take it as early as 9:30. You have exactly 60 minutes to take it. If you are taking it online, I'm going to be posting a Proctorio practice exam today so that you can ensure that your computer is good to go or your setup is good to go. And if it's not, then you need to figure something out, borrow a laptop or something like that. Um, but, and I don't say that like borrow a laptop, just go and borrow one. But I mean, communicate, like talk with your peers or something like that. Okay. If anything comes up, please email me. Other than that, I hope you have a good one and I hope you all do well on the exam. Thanks.